Okay, so we're going to have a look at another question from the 2022 HSC Advanced Maths paper. So this is question 25. We have been told to let f of x, so let f of x equal sine of 2x. Then we're told to find the value of x for which x is greater than 0, less than pi. So find the value of x for x greater than 0, less than pi, for which the first derivative is minus root 3 and the second derivative is 2. All right, so first we're going to take the derivatives, f prime of x, and we'll graph them as we're going along. Actually, this graphs will really help in this question. It's very convenient. So f prime of x is going to be 2 times cosine of 2x, and then f double prime of x is going to be equal to minus 4 sine of 2x. So if we draw sine of 2x between 0 and pi, this will just be a single repetition of the sine function, like this, because 2 pi says it repeats twice from 0 to 2 pi, so if we're going to 0 to pi, it just repeats once. So this is pi on 2, this goes from 1, minus 1, this is the y-axis, this is the x-axis. Now, first derivative is the cosine function, and the period in this case again is going to be pi. 2x means it repeats twice within 2 pi, so that means it repeats 1 within pi. Its amplitude, however, is 2. So it goes up to 2, down to minus 2. So the cosine does this. And then the second derivative, let me try and fit these all on the screen together. Let me move this up a little bit, move this one up a little bit. We have our second derivative function is then minus sine, still repeats once between pi. Its amplitude is now 4. So it goes up to 4, down to minus 4. So it does this, up here, and down here. So immediately, if f prime of x is equal to negative root 3, negative root 3 is about minus 1.4, something like that. So this is sorted down here, negative root 3. It is one of these two solutions, this one or this one. However, if f double prime of x is equal to 2, this is 2 here, it is one of these two solutions. Well, it can't be this solution and it can't be this solution. It must be the x value of these 2 points. So now all we have to do is we have to find what this x coordinate is, and then we're done. So we can use the second derivative to do this. We can say, we can use the first derivative to do this. We can say that we find the negative square root of 3 has to be equal to 2 times cosine of 2x. This implies that cosine of 2x is equal to negative root 3 on 2. So cosine of 2x is equal to negative root 3 on 2. We could just solve this normally. We could let 2x equal t. We've got cosine of t is equal to negative root 3 on 2. So if we draw a new cosine function, does this, negative root 3 on 2 from our special triangle, or root 3 on 2 from our special triangle. This is 2, this is root 3, this is pi on 6, is pi on 6. So this value up here is root 3 on 2. This is pi on 6. Because this cosine curve has rotational symmetry, and this is pi, the solutions to the negative are pi on 6 down from pi, which is 5 pi on 6, and pi on 6 up from pi, which is 7 pi on 6. These are the two values at which the function evaluates to minus root 3 on 2. So this means when we're solving cosine of 2x equals negative root 3 on 2, we find that 2x is equal to 5 pi on 6, or 2x is equal to 7 pi on 6. These are the two possible solutions. These are the two solutions we found in this cosine function. The lower one we know is not valid. So this one is going to be a smaller number. This is not valid. We worked this out from looking at our graphs. So this must be our correct solution. Divide both sides by 2, and we find therefore x equals 7 pi on 12 is the solution that we're after. And this value, just to confirm this value is between 0 and pi. Right? So it satisfies both the derivative and the second derivative. It sits within the bounds. We found it through solution, so this is definitely our answer. So you can do these questions a ton of different ways. This was one way to do it. You don't have to use graphing. You can do it entirely algebraically. The graphing was just very convenient because the graphing helped us eliminate certain possibilities. It told us which of the possible solutions in terms of their magnitudes or signs or places were most likely to be correct, and that essentially at the end of the question gave us the correct solution. So now, in terms of marking, you get a mark for attempting to find a value for x that solves both of them or equivalent. So if you're doing graphing, you'll get a mark for graphing or something along these lines, or some algebra that tries to get a solution. You'll get a second mark for finding values of x between 0 and pi for each derivative. So if you start taking the derivatives and start solving those equations, it'll get you the second mark. And then to get the third mark, you have to identify of all the solutions you find, which one is the correct one. So this is how we do this question.